Okay, hello everyone. Let's go ahead and talk about section 18C, which is theoretical probability. Now, let's go back to the coin example that we were dealing with before that dealt with experimental probability and relative frequency of an event occurring based upon how many times we actually perform the trial. So let's say, for example, again, that we flip our coin. And let's say, for example, that we come up with a coin that has a 50% chance of falling heads and a 50% chance of falling tails. And let's say, for example, that we do it another 10 times. And let's say, for example, that we come out with this. So notice that, again, if I go ahead and create a frequency table, here are the number of heads that came out when I flipped it 10 times. And here's the number of tails that came out when I flipped it 10 times. So notice that if I was to use the values based upon our frequency chart, I could then go ahead and talk about the experimental probability of coming out with the heads, which is the number of heads that actually showed, divided by the total number of trials. So notice that in this case we have 4 over 10, which means that out of 10 times that we performed the trial, there was actually 4 times where head actually showed. Okay, and we could do the same thing for the probability of t using the idea of relative frequency. Now the thing is though, of course, what would happen if I went ahead and did this experiment 200 more times? What if I did this experiment 5,000 more times? What if I did this experiment 1 billion more times? Now, of course, who's actually going to be doing this experiment 1 billion times? Well, when you think about Las Vegas has what they deal with, like dice. Who would roll the dice 1 million times? Well, I'm sure that in a year, each dice is rolled probably more than 1 billion times, I'm sure. So what happens then is that even though we know that this is a 50-50 coin in terms of the chance of it coming out with heads or tails, notice that the relative frequency, of course, is coming out different. That's 40%, that's 60%. But if we were to go ahead and continue rolling it over and over and over and over and over again, we would actually come up with something different. And that's based upon theoretical probability results. Now, the way that we calculate theoretical probability as opposed to experimental probability, we basically take a look at the probability of the event occurring. And in that case, what we will say is that that's the probability of E. Let's use the capital letter E for the event occurring. And what we would calculate then is we would not calculate anything based upon relative frequency, but we would base everything upon the sample space that we have. And notice that what we're doing then is we're taking a look at the number of outcomes that you have in the sample space. And we're actually dividing the number of outcomes that you have in the sample space that represent that particular event happening. So let's go ahead and take a look at how we would use this. If we go ahead and take a look at the coin, let's go ahead and talk about the probability of actually having a head. Now, the main thing, of course, is that we need to go ahead and establish what the sample space is. So the sample space, which is U, is going to be either heads or tails. Okay? And there you go. So what we know then is that the number of elements, the number of heads in the sample space is 1. So let's go ahead and say that this is 1 divided by the total number of outcomes in your sample space, which in this case, of course, is 2. And so that's where we can come out with the theoretical probability of getting a head using a fair coin, and we could verify that yes, in fact, the probability of getting a heads is 1/2, or in other words, 50%. So even though the experimental probability with the relative frequency is going to come up with things that are different, of course, because the trials will be different, what the outcomes of the trials will be different. In the end, if we were to do this 1 billion times, 1 million times, a trillion times, then of course what we would come closer and closer to is this relative frequency would get closer and closer to these values here. Okay, so that's how we go ahead and calculate theoretical probability. It's just a matter of, can you actually go ahead and determine all the outcomes of your sample space, and after that, can you count? Okay, so let's go ahead and take a look at some key concepts and some key facts again, based upon what we're talking about here with theoretical probability. Now notice that some of the key facts that we have with experimental probability still is the same for theoretical probability, in the sense that if we have the probability of an event occurring, then that probability has to be greater than or equal to 0 or less than or equal to 1. Okay? Now we also talked about complementary events in the IGCSE course, and this is again how we go ahead and describe that. We say that if E is an event, then E prime are all events that do not include E. So for example, we can then go ahead and say that the probability of E plus the probability of everything that is not E would then of course be equal to 1. Now let's take a look at an example of why that's true, and let's use the situation here. Now let's go ahead and talk about the probability of heads, and notice that the probability of H prime is really the same thing in this case as the probability of getting on tails. So what I can say then is that the probability of H plus the probability of H prime, of course, has to be equal to 1. We already went ahead and showed that the probability of H is 1/2 plus the probability of H prime equals 1. So therefore, we can say that the probability of H prime is also going to be equal to 1/2. So notice that what we talked about then is that the probability of T, or the probability of getting a tail, is also 1/2. And that makes sense. Okay, so there you go. There's the relationship between experimental probability, relative frequency, with theoretical probability. And notice that there are some very consistent facts with regards to both experimental probability and theoretical probability that we can use in terms of actually calculating theoretical probability results. Okay, so good luck with theoretical probability, and see you next time.